The earth continuity test is used to verify that there is a good electrical connection between any exposed metal parts and the protective earth pin in the mains plug of a Class 1 appliance. As we can see, the appliance is plugged into the PAT and the test probe is connected to exposed metal parts. Current is then passed from the PAT tester through the protective earth conductor of the mains cord to the enclosure. It then flows back to the PAT tester via the protective earth conductor. The PAT will then display the resistance of the protective earth path. Insulation testing is carried out by plugging the tested appliance into the PAT and applying a test voltage of 500 volts DC to both the live and neutral terminals of the mains plug. If the insulation is in good condition, a high insulation resistance reading is obtained, typically in the order of hundreds of megaohms. If there is a breakdown in insulation between live parts and protective earth, a current will flow across the insulation and back to the PAT via the protective earth conductor. The measured insulation resistance is greatly reduced, indicative of an insulation fault. When testing insulation on a Class 2 appliance, the test probe is connected to any exposed metal parts. If the exposed metal parts are insulated from live parts, a high insulation resistance measurement is obtained. If there is a breakdown in insulation between live parts and any exposed metal parts, a current will flow across the insulation and back to the PAT via the test probe. The measured insulation resistance is greatly reduced, indicative of an insulation fault. To measure a protective conductor current, the appliance is plugged into the PAT. When the appliance is energized, current will flow from the main supply to the appliance in the live conductor, indicated via the brown arrow, and then return to the supply via the neutral conductor. If there is good insulation between live parts and protective earth, the live and neutral currents are equal, i.e., all of the current entering the appliance in the live conductor returns to the supply in the neutral. If there is a fault with the insulation, some of the current flowing in the live conductor will return to the supply via the protective earth. The PAT will detect this imbalance in the live and neutral currents and display the result. The touch current test is carried out by connecting the PAT to the appliance and the test probe to any exposed metal parts. If there is fault with the insulation, some of the current flowing in the live conductor will return to the supply via the test probe. The PAT will measure any touch current returning via the probe and display the result. The flash or dielectric strength test is carried out by applying a high voltage, typically 1500 volts AC, to both the live conductors of the appliance. If there is any breakdown in the insulation, the PAT will measure the current flowing through the insulation to protective earth. A test probe is required when testing a Class 2 appliance. The probe is applied to any exposed metal parts. If there is any breakdown in the insulation, the PAT will measure the current returning via the test probe. An RCD is tested by connecting it to the main supply and using the tester to generate a fault current equal to the rated current of the RCD. As the animation shows, the fault current will trip the RCD and the tester measures the trip time.